Okay, great. One more module. This one is easy. It's not like the last one. We're over the hill on the tough statistics, at least for today. So, as it turns out, there are different aspects to statistics that are not well known or not well understood and are tricky. And this is what the module right now is going to go over. And I think it's kind of fun because there's some usual things that are cool. There's some unusual things that are a little bit disturbing. It's sort of like, okay, when I took my first law course, you know, kind of just environmental law, it's like, now I know when to call my lawyer because I know enough to be dangerous. And that's sort of this module's purpose. As I said before, and there's a debate whether it was actually Mark Twain or Disraeli who said lies, damn lies, and statistics, and how do we tell them apart? Well, you probably need a statistician, but if he's a liar, you know, how do you know if he's telling the truth? So it's a problem. Now, we have different areas within the statistical realm. We have descriptive statistics, things like means, variances, the population, parameters, and so on. We have inferential statistics. Those are things that infer what's going on. Things like confidence intervals, okay? Or maximum values. What's the highest value? Where we make predictions. We take data and we infer what's going to happen in the future or in other locations based on the data we collected. And then it's all grounded essentially in probability. What's the probability of this? What's the probability of that? And really, probability is where kind of the confusion and the trickiness comes into statistical analysis. One of the issues in statistics is that we use inductive versus deductive logic. So, kind of in a philosophy class here, deductive logic is straightforward, easy, and verifiable. We say all humans are mortal. Okay, we know that. Everybody dies. Socrates is human. That means he's mortal. That means he's going to die. Okay, the syllogism works. It always holds together. Okay, that's not true in the statistical world because we do inductive logic. Okay, before we were looking at hard truths. Okay, now we can say Hitler was a dictator and was ruthless. Okay, you could even debate whether either of these statements is correct. But assuming they're correct, we can then say Stalin was the same thing, and then we now have this new guy, Kim Jong-un, and he's probably ruthless. Because he's a dictator, he's probably ruthless. Does that hold together? Might. It might not. Okay? So what are we doing in the environmental sampling world? We're saying these samples said the pile is clean. Did you sample the whole pile? No. But I said it was clean to sample the whole pile? No. We are inferring that the whole pile is clean. In other words, every dictator is ruthless because these two were. We're saying because these 3 incremental samples showed the pile is clean, the whole pile really is clean. We may, as Tressa said, we got a 200-foot pile. We missed a few spots, okay? We don't know for a fact. We know as well as we can know. That's our problem because we never know the whole thing. And we can't send the whole pile through an analytical instrument, okay? It just doesn't work. So that's our challenge, okay? We are inferring the general case from specific data, okay? Whether you're a dictator or whether you're a sample, we're taking that and inferring that to a larger case, which may or may not be true.